Hi everyone. Yes. I hope I am audible. Am I audible, ma? Am I audible? Yeah. Okay. Yeah. Yes, ma. Okay. Thank you. Pratyusha, good evening. Nagalakshmi, Dinesh, Abhinaya, Ramya, Manaswini, good evening. Good evening, all of you. Audible. Okay. Thank you. Thank you. So, shall we start? Welcome to Gita's classes. And today we are going to do some more problems and we are going to practice some theorems also. Okay. So in the previous class, do you remember whatever we have done? Have you practiced once again? You have to practice. We are going to clear COSM this semester. Okay. So for that, all the efforts I am putting for you and I am expecting the same effort from your side also. Right? Okay, Sairam. Okay, ma. Good evening. Yeah. So now in the previous class we have studied our additive theorem, and today we'll additive theorem for two sets we have done, that is P of A union B is equal to P of A plus P of B minus P of A intersection B. This is additive theorem for two sets. Okay, additive property or additive theorem for two sets. And now we are going, all of you are ready with notebook and pen, I think, right? Yes, come on, we'll start. You please write, otherwise you will not be able to remember. Okay, when you write, it will be like twice studying, right? Therefore now let us extend this for three sets. P of A union, all of you start writing along with me, right? P of A union B union C. What we are going to do is P of, you split it into two so that we can apply the theorem for two sets, right? So let us take A union B as one set and C as one set, not plus union. A union B union C. Let us treat A union B as 1. Therefore, by using two sets now, P of A union B plus P of C minus P of A union B intersection C. P of A plus P of B minus P of A intersection B. In the place of A we have A union B. In the place of B we have C. Right? So A union B intersection C. Now again apply the theorem for A union B. P of A plus P of B minus P of A intersection B plus P of C minus. Now which theorem you will apply now? This is distributive law you have to apply. What is that distributive law? For example, 5 plus 3 into 8. What will you do now? You can write this as 5 plus 3 into 5 plus 8, right? 5 plus 3 and 5 plus 8, right? In the same way, this is called distributive law, right? So this is equal to P of A intersection C union B intersection C. P of A intersection C union B intersection C. Actually A with C, B with C, and whatever is there in the center, it will come in the center here also. Okay. So this is equal to P of A plus P of B minus or plus P of C, I'll write here, P of C minus P of A intersection B minus, and again here you have two sets. Apply the same theorem for two sets here. So minus of P of A intersection C plus P of B intersection C minus P of A intersection C intersection B intersection C. Right? So this is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of A intersection C minus P of B intersection C, and this minus and minus it will be plus. So plus P of A intersection. Again C intersection C is C only. So only once you can write A intersection B intersection C. This is the proof for three sets. Right? So all of you please write in a notebook. Good evening Kirtika. All of you please write. Over. Shall we go to the next one? Yes. All of you please write. It will be useful for you. Unless otherwise you write, you can't remember. It will be difficult. Okay. Towards the end, it will be very difficult. Overnight, you cannot do wonders. That too in mathematics. So slowly let us study. Right? Yes. Next is Bayes theorem. Very, very important theorem. Last time they asked for statement. Sometimes they'll ask for the proof also. State and prove Bayes theorem can be asked. You can say Bayes rule or Bayes theorem. What is the statement, all of you? Please write the statements. If the events, along with me you also write. If the events B1, B2, etc. Bn constitute a partition of sample space S, of the sample space S, where P of Bi not equal to 0 for I is equal to 1, 2, 3, etc. up to n, then for any event A, in S such that P of A not equal to 0, then P of, this is important, Bk given A is equal to, you can write this as P of Bk intersection A divided by sigma I varies from 1 to n P of Bi intersection A. If you expand this using conditional probability, you can write this as A given Bk into P of Bk divided by, here see, remember like this, if Bk given A, if you want, you have to just reverse it, A given Bk, and after given whatever is there you have to write here. Remember like that. Okay. Then in the denominator again same thing, sigma I varies from 1 to n P of A given Bi. It is only for K we have written, that is only one value. It may be 1, it may be 2, it may be 3, anything, only one. But everything in the denominator. Okay. Denominator you have to write all. So A given Bi into P of Bi. That is P of A given B1 into P of B1 plus P of A given B2 into P of B2 and so on. We have done a problem in this, right? Same. Yeah, Shrutika, good evening, Mom. Yes, right? Have you written? By heart now itself, if the events B1, B2, etc. Bn or a partition. These sets are a partition of the sample space capital S where P of Bi. This is a condition that probability should not be equal to 0. Okay, it should not be equal to 0. So P of Bi not equal to 0 for I varies from 1 to n. That means each probability should not be equal to 0, right? Then for any event A in S such that P of A not equal to 0, P of Bk given A is equal to. Always remember, whatever you are writing, that K alone will be there in the numerator and in the denominator from I varies from 1 to n. Just replace K by I, right? Yes, shall we prove this? Yeah, proof. I believe in writing. If you write, it will be very useful for you. Okay, it will get registered in your mind. That is why this class is mainly for that only, to make you write. Okay, just by reading you can't remember things. If you write, you will never forget. Just one glance before exam, one glance is more than enough if you are thorough with the theorems. Okay, thorough with the problems. Right, let B1, B2, etc. That's why I am also writing for you. B1, B2, etc. Bn or n events such that P of Bi is greater than 0 and Bi intersection Bj is equal to empty. That is, they are disjoint. For I not equal to j, where I and j are varying from I comma j, or taking the values from 1 to n, right? Also B1, B2, etc. Bn are exhaustive events. Already we have seen what is exhaustive event and mutually exclusive. All these definitions are available in the channel. If you want, you can go through once. Okay. So exhaustive events of S, and A is any other event of S, that is other than B1, B2, etc. Bn. Okay. Other event of S where P of A greater than 0, Consider these sets. Now, this you have to remember. Now consider capital S. We know that what is our assumption? B1, B2, etc. Bn are exhaustive events, right? Therefore, what is our capital S? B1 union B2, etc. union Bn, right? Now, we know that A is any other event of S. That is, A is equal to A intersection S. Shall I write like this? See, this is the sample space S. And this is the set A. What is our A intersection S then? It will be A, right? So I can write A as A intersection S. Okay. That is, what is our S now? Just now we have assumed that B1, B2, etc. Bn are exhaustive events, right? So B1 union B2 union etc. union Bn. A intersection B1 union etc. Bn. Now you apply distributive law. That is A intersection B1 union A intersection B2 union etc. A intersection Bn. And what do you know about these sets? We know that B1, B2, etc. they are all mutually exclusive, right? Therefore, A1, A2, A1 intersection B1, A intersection B1, A intersection B2, etc. they are also mutually exclusive. So, A intersection where A intersection B1, then only we can apply our axiom 3, right? As we have seen in the additive theorem, where A intersection B1, A intersection B2, etc. A intersection Bn are mutually exclusive. right? So now what do you want? P of bk given A. Okay, we'll write in a fresh page. P of bk given A only we want, right? That is P of, by definition of conditional probability, we know that P of bk intersection A divided by P of A, right? This is by definition of conditional probability. That is, what is our A? Just now we have seen that it is A union, A intersection B1 union, A intersection B2, etc. Okay. So now I am going to write that, replace that. That is P of, in the numerator it is BK intersection A. I am teaching you slowly so that you can also write along with me. Understand and write. Okay. So P of A intersection B1. This is what we have done. No, A is equal to here. In this, from this step I am writing. This is our A. So for P of A I am going to write the right hand side. Right? So P of A intersection B1 union A intersection B2 union etc. A intersection Bn. Right? Now this can be written as P of bk numerator you write as it is divided by, because these are all mutually exclusive, I can use axiom 3 and write that as A intersection B1 plus P of A intersection B2 plus etc. plus P of A intersection Bn. Just like that you cannot write. Now because these sets are mutually exclusive, I can write like this. Okay. Yesterday in the additive theorem, in the previous class we have seen in the additive theorem. Now you expand it. P of A given Bk into P of A by multiplicative theorem, right? Same thing in the denominator also. P of A given B1 into P of B1 plus P of A given B2 into P of B2 plus etc. plus P of A given Bn into P of Bn. Okay? If you have any doubt, you ask me. Just using, I have applied multiplication theorem. If you want, you can write sigma. In terms of sigma, it is bk given A is equal to P of A given bk into P of bk. Instead of writing all these steps, I can write it as I varies from 1 to n. Sigma I varies from 1 to n. P of A given bi into P of bi. This is the theorem, hence the proof. Okay. Hi Divya. Yes ma, no doubt. Okay, thank you. Yes. Yes ma. Actually disjoint, then you can add the probabilities. Separate probabilities we are adding no here. From this step to this step. Shrutika, from this step to this step, P of, what is axiom 3 says that P of A1 union A2 union etc. union AN can be written as P of A1 plus P of A2 plus etc. P of AN. We can write if they are mutually exclusive. As even they should be mutually exclusive. If you want to speak about the in terms of sets, they should be disjoint. Okay. Understood, Shrutika? Yes, ma. Disjoint or disjoint in terms of sets. As evens, they should be mutually exclusive. Yes, got it? Shall we go to the next one? Yeah, using the base theorem, you have to do this problem. All of you please try to do this. First you start, I'll also do. Okay, okay, ma. Yeah, just read the question once. Two factories produce identical clocks. The production of the first factory consists of 10,000 clocks, of which 100 are defective. The second factory produces 20,000 clocks, of which 300 are defective. What is the probability that a particular defective clock was produced in the first factory? Okay, understood. Yes, ma. Thank you. Yes, good. Good, Shrutika. Yeah. See, please remember, you try to understand the concept so that any kind of problems, if they give in the university, you will be able to do it easily. Okay. Of course, you have to practice many problems because practice makes permanent. Generally, we say that practice makes perfect. It is more than perfect. It will make permanent. Permanent in the sense, it will be stored in your mind. That is why repeatedly I'm taking the classes again and again. I'm repeating because it will be there in your mind. Okay, it will get registered in your mind. So if you understand the concept, then you will be able to do any kind of problem. It is not at all difficult. Okay. Now a small twist is there. You have to find out. What is our A? What is our B? There are two factories. Let us assume that there are two factories A and B. Let us take assume two names. The factories are A and B. Can you tell me what is P of A? See, the production, they are producing identical clocks. They are producing identical clocks. The production of the first factory consists of 10,000 clocks, of which 100 are defective. The second factory produces 20,000 clocks, of which 300 are defective. What is the probability that a particular defective clock was produced in the first factory? Can you tell me what is, we have to find out P of A and P of B. Yes. Can you tell me what is P of A and P of B? Then you have to find out P of D given A. Try to find out A and B are two factories. D is for defective. Okay. So find out P of D given A and P of D given B. No ma, it is not 10,000. It is not 10,000. Any other answer, Shrutika? No ma, think once. Always remember, probability should be a value between 0 and 1. Okay. Probability should be a value between 0 and 1. Anyone else? What is P of A? What is P of B? The production of the first factory consists of 10,000 clocks, of which 100 are defective. Yeah, it is 0.01. Yes, ma, correct. Manaswini, correct. P of, very good. P of D given A is 0.01. Yes, very good. Yes. See, 100 are defective out of 10,000 clocks. Okay. 100 are defective out of 10,000 clocks. Therefore, 2 zeros you will get cancelled. 0.01 is correct. Yeah. P of A is 1 by 3. Excellent, Nagalakshmi. Very good. Very good. Yes, excellent. Yes, ma. Manaswini, excellent. P of D given B. Yes, yes, yes. Correct. Point. This is P of D given B will be 300 are defective out of 20,000. Yeah, 1 by 3. Yes, Nagalakshmi, it is correct. Why are you deleting? It is correct. Yes, ma. Dinesh, 0.03. Which one? Please don't delete, ma. It's okay. No problem. You are all human beings. No problem. And this is not a university exam. Okay. Even if you make mistakes, nothing wrong. Right? You have to do. Then only you can remember. Even if you make mistakes, it will be, you take it as positive. Right? So this is 300 by 20,000. This is 300 are defective out of 20,000 clocks, right? So 0.015. All of you please post your answers. Nothing wrong. Even if it is wrong, we are not going to get any punishment, okay? So unless otherwise you practice, you will not be able to remember. Yeah, what is P of A, ma? Nagalakshmi, you have given correct answer actually. Yes, others? Shrutika, 10,000 you cannot have because it is a probability, ma, out of something. 10,000 clocks are produced by first factory and the second factory produces 20,000. So total number of clocks are how much? 30,000. Yes, Nagalakshmi, 2 by 3 is correct. Very good. Very good. Yes, ma. What about others? Please try to understand. Shrutika, it is 10,000 out of something. What is the total number of clocks produced by both the factories? It is 30,000, right? So 10,000, first factory A is producing. See, first factory A is producing 10,000 clocks, out of which 100 are defective, right? And B is producing 20,000 clocks, out of which 300 are defective. Okay, understood? Yes, ma. Yes, Nagalakshmi, P of A is 1 by 3, P of B is 2 by 3. Excellent, very good. Manaswini, she has given P of D given A and D given B. Yes, both are correct. Excellent. Very good, very good. Others also please come. Final answer 1 by 4. Let us see. Even I have not done ma. Let us see. See 100. So P of A is 10,000 out of 30,000. Total is 30,000. Total products are 30,000. Okay. So P of A is 10,000 out of 30,000. Therefore it is 1 by 3. P of B is 2 divided by 3. And P of D given A P of D given A is 0.01 and P of, I'll write clearly, D given A. That is, you are considering the product A in which D is defective. That is, you are selecting A and you are considering all the defective products in that. Okay. So, P of D given A is 100 by 10,000. It is 0.01. Similarly, P of D given B is equal to 300 divided by 20,000. That is 0.015. Okay. Now what do you want? Actually, P of A given D. Actually, you are taking as a defective product. What is the probability that it has come from the first one? That is P of D given A into P of A divided by P of D given A into P of A plus P of D given B into P of B. Yes, Dinesh Reddy 0.01 is correct for P of D given A. Yes, very good. Very good. All of you please try. All of you post the answers. No problem. This is not university exam. Okay. Yeah, final answer even I have to do it. You substitute the values. In the numerator you will have D given A. P of A given D is equal to substitute the values. Substitute the values now. 0.01, right? P of 0.01 into 0. What is P of A? 1 by 3, right? So 0.3 substitute the values, ma. I'll take 2 or 3 digits you can take, or 0.33 you can take, divided by, in the denominator you will have the same thing. So 0.01 into 0.33 plus 0.015 into 0.67 you can say, or 0.667 you can, 0.67. So Nagalakshmi, you got 1 by 7. Okay, ma, let me check. Even I have not done. Point 0.015 into 0.67, right? And in the denominator you will have 0.01335, and numerator you will have 0.0033. Yeah. I got 0.2417. 2472. 0.2472. Anyone got this value? 2472, ma? Lomit, you got 0.024. The values are right, no? 0.01, D given A is 0.1 and P of A is 0.33. 1 divided by 3, so 0.33. And in the denominator 0.01 into 0.33 plus 0.015 into 0.67, right? P of B. 0.247. Yes, ma. Divya, you got. Yes, ma. Correct. 2719. Okay. 2719. Yeah, 247 is fine. Yes. Yes, very good. Very good. Yes, ma. Yeah, okay. Lomit, you are right then. Yes, correct. Very good. Very good. Divya, Lomit, you got correct value. Manaswini, you check the answer once. 1 by 300 divided by 1 by 75, no ma. Somewhere you have made a mistake, maybe. 1 by 75, how did you get? Is it, check these values once again. In the denominator, you check the values once again. Denominator you check, Manaswini. Point 2472 is correct. Yeah, of course it is right. 1 by 4 is 0.25, you can say ma. Yes, correct only. 1 by 4 is almost, it is similar. Yeah, 0.25, it is nearby value only. Correct only, Manaswini. Yes. Correct. 1 by 75, 1 by 300. Yes, ma. Correct. You can consider 0.245. Because why we are getting that difference? Did you get it? Here I am considering 1 by 3.33 only, no. Actually this value will be 0.3333 etc. Right. Similarly 0.66667, it will go like this, right? That is why that difference. We got 0.247 and if you round it you will get 0.25. Actually exact value should be 0.25 only. If you take LCM, yeah, Manaswini, what you have done is correct. 1 by 300 divided by 1 by 75. Without simplification, I mean without considering the decimals, if you proceed like this, what she has done is correct. P of A, here it is to be considered as 10,000. It is 1 by 100. You can keep this as 1 by 100 as it is. Here 3 by 200 as it is. Then 1 by 3, 2 by 3. You can keep it like that. 24719 is correct, Dinesh ma. Very good. Very good. Everyone has done correctly. Because we have, this is the difference. Why we are getting that difference means here 0.3333 we are getting, no, that is why that difference. No problem. No problem. Okay. Yes. Next question. If two dice are thrown, what is the probability that the sum is greater than 8 and neither 7 nor 11? Two dice are thrown. All of you know when you throw a die, how many sides numbers will be there? 1, 2, 3, 4, 5, 6. All the others also should do. Okay. Please post your answers. No problem. You can post your answers. Even if you make a mistake, no problem. Yeah. So for this already I have shown you. This is the sample space. When two dice are thrown, this is the sample space capital S. Capital S is equal to this one. So greater than 8 means what? It may be probability that x is equal to 9 or 10 or 11 or 12. So P of 9, x is equal to 9 plus P of x equal to 10 plus P of x equal to 11 plus P of x equal to 12. Can you quickly tell me? 8 by 36, 5 by 18. Yes, ma. Yes, correct. One second. Five by 18 is correct. Shrutika, you have left 2. It should be 10 by 36, ma. Actually, for 9, what are all the values? 3, 6, 6, 3. 4, 5, 5, 4. Right, for 9. I'll write the values once. For 9, it is 3, 6, 6, 3. Then 4, 5, 5, 4. 4 values. So 4 divided by. So for 10, it is 4, 6, 6, 4. Then 5, 5, right? For 11, it is 5, 6 and 6, 5. Yes. For 12, it is 6, 6. So totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 divided by 36. Shrutika. It is not 8 by 36. Divya, correct ma? Very good. Others? Others? So 10 by 36 or 5 by 18 is correct. Next one, neither 7 nor 11. So what you have to do is 7 or 11 you have to find out. Then subtract from 1. So probability that neither 7 nor 11. Actually, these two problems I have given already yesterday in the previous class. That only I am doing. So neither 11 nor neither 7 nor 11 means 1 minus P of either 7 or 11. Yeah, 7 by 9. Divya, excellent. Very good. Very good. Yes, ma. 7 by 9 is correct. Yes, final answer is 7 by 9. This either 7 or 11 already we have done. It is available in the channel. If you want, you can detailed explanation. You can go there. So it is 7 by 9 we have found out. And this is, sorry, 2 by 9 actually. Either 7 is 2 by 9. Therefore, the final answer is 7 by 9. 1 minus 2 by 9. Okay. So it is 7 by 9. Next question. 3 cards are drawn from a pack of 52 cards. What is the probability of getting 1 ace, 1 jack or 1 king? Can you do it quickly? And I have given already. This is the table you can remember. Okay, from this, if you remember this table, it is very easy for doing the problem. What is the question? 3 cards are being drawn from 52 cards, and what is the probability of getting 1 ace, 1 jack and 1 king? No, ma. You have to select 3 cards, no. 3 cards, no. In that, 1 should be ace, 1 should be jack, 1 should be king. See, 3 cards I want. So, 1 ace I want to take and 1 jack I want to take and 1 king. Actually, with this 1 ace, it is not over. So, this should happen, and this should also happen. Okay. So, 1 ace, 1 jack and 1 king. And means multiplication. Now, how many aces are there? 4 aces are there. From 4 ace cards are there. Right? So, from this I am taking 1. So, it is 4C1. And how many jack cards are there? 4. Therefore, 4C1. And how many kings are there? 4 kings are there. So, 4C1. It is not 4C3, ma. It is 3 different. 3 different, Shrutika. 3 different cards are there. Okay. Because it is and, you have to multiply. This is the favorable cases. So, required probability is 4C1 into 4C1 into 4C1 divided by, and in the denominator you will have 4. So 52C3. Totally there are 52 cards. Shrutika, denominator is correct, 52C3. Numerator it is different, favorable cases. That is what is the given condition. You have to accept, you have to write according to the given condition. Okay. So here 1 ace, 1 king, 1 jack and 1 king. So all the 3 should happen. Therefore, you have to simplify this. So 4 into 4 into 4 divided by 52 into 51 into 50 divided by 1 into 2 into 3. That I will write in the numerator. That is 1 into 2 into 3. When you simplify, you will be getting 52C3 is in the denominator, Dinesh. Yes, ma. Yes. 52C3 in the denominator. That is total number of probability. Total number of possible cases. Okay. So, this is 52 into 51 into 50. So, here 1, 4 you can cancel. And remaining also you can cancel. The final answer you will be getting 16 divided by 5525. Yeah, Divya, you can check this answer. 16, you simplify this 3 factorial divided by 52 factorial and all. I didn't understand. How did you get 3136? I didn't get it, ma. Into 3 factorial divided by 52. You please go through the video. In my class, I have explained in that basic probabilities. Okay, probability, the same thing, same problem I have done in that. If you want detailed explanation, please go there and watch that. Okay. So final answer is 16 divided by 5525, right? And one more question. Last question. 3 cards are drawn in succession without replacement. Without replacement. So this is a clue for you that they are dependent event. They are not independent. So whenever they are not independent, you have to go for conditional probability. Okay. So quickly I'll explain. Please you also practice this problem. See, there are A1 is the event of first card is a red ace. So A1 is red ace, ace card. What is A2? Is the event that the card is a 10 or a jack. 10 or jack. What is A3? That the third card is greater than 3 but less than 7. Greater than 3 but less than 7. Which one? 0.0002. The final answer you are telling. 1 second. Yeah, 0.0028 is right, Dinesh. Correct, ma'am. Correct. 0.0028 is correct for the previous question. Yes. Correct. Very good, Dinesh. Yeah, now 3 cards are there. So 3 events are there. A1. See, first I am taking A1. A1 is happening. And after once I pick up the first card, I am not replacing it. That is without replacement. Okay. So P of A2 depends on A1. After A1 happens, then only A2 is happening. After A1 and A2 happens, A3 is happening. Okay. So what is the required probability? We want P of A1 intersection A2 intersection A3. Find the probability that the event A1 intersection A2 intersection A3 occurs. Okay, so what is this probability? First A1 is happening, then P of A2 is happening, but it depends on A1. Okay, similarly A3 is happening, but before that A1 and A2 are happening. Right? So now, how will you find out this now? P of A1. A1 is what? Red ace. How many red ace cards are there? See, 2 cards are there. Right? So totally there are 52 cards. I am taking 1. First event is taking 1 card. Right? So it is 2C1. 2C1, correct. 2C1 divided by 52. Right? Into A2 given A1. How many A2? 8 now. After I am taking 1, 52C1. I am taking the first red ace card. Yeah. Now I am taking this first one. Now after this, how many cards will be left? Only 51 cards are available now. Now the status is only 51 cards are there, right? So 51. In that, what is the favorable event? 10 or jack. How many 10s are there? 4. And the 4 jacks are there. Okay. So totally there are 8. So from that I am taking 1. So 8C1 divided by 51C1 into how many cards are left? We are left with how many more cards? Only 50 because I have taken 2 cards. So 50C1 and what is the favorable event now? Greater than 3 but less than 7. Can you tell me how many cards are left? Can you tell me now? Can anyone tell how many more cards are there? Quickly. It should be, I'll show you this table now. Tell me how many more cards are there. Greater than 3 but less than 7. Greater than 3 but less than 7. How many more cards are available? Favorable cases, how many more are there? Greater than 3, less than 7. Yeah, 50 is left with 50. Yes, very good, Divya. Denominator 50. Yes, ma. Numerator. How many are favorable? Greater than 3 but less than 7. Strictly greater than 3 and strictly less than 7. It is not greater than or equal to. Okay. So greater than 3 and less than 7. How many more cards are there? Which rows, which columns you will consider now? Greater than 3. Will you consider this? 3. 12. Yes, very good. Nagalakshmi, very good. Yes, very good. You are not supposed to consider 3. You are not supposed to consider 7. Okay. Yes, Dinesh Reddy, 12. Very good. Correct, ma. Correct. Divya, got it? 12. Okay. So 4, 5, 6. There are 4 cards here, 4 cards here and 4 cards here. So totally there are 12. Understood all of you? So 12 C1. This is the third one. And you can simplify. Okay. You will be getting, I think it is 8 by 5525. 8 divided by 5525. Eight by 5525. This is the answer. Hope all of you got. So we have come to the end. So today it is enough. And I want to know, next week Monday you have lab, Noma, lab exams. So shall we have classes on Monday, next Monday, Wednesday? Is there any problem or shall we proceed with this? Monday shall we have class or not? Monday, Wednesday, Friday next week shall we have or not? Please respond. Second card we have R in between, no. So then why should we multiply 4C1? 1 second. Listen, ma. We can have class. Okay. Okay, thank you. Divya, please listen. P of A1 should happen. Actually, I am taking one card. Okay. Then P of A2 is there. R means we are not multiplying. It is 8C1, 4C1 plus 4C1 only here. I think this is your doubt, right? Whenever you have R, it should be add. You should add. You should not multiply. Whenever, always remember, for R, whenever you have R, you have to add, addition, plus. Whenever you have and, you have to multiply. Please remember that. Okay. Yeah, 4C1 plus 4C1 only. You should not multiply. R means addition. Okay. And in the basic classes, I have explained very well. Slowly, I have explained everything. You can go through once. You will, I think you are getting doubts in that cases only. I have given with enough number of examples I have explained so that you will never get doubts in that if you go through that classes. Okay. Yes, ma. Yes. Okay. We can have class. No problem. No, Monday. Wednesday, I think Tuesday if you have. Even if you have practicals, this 40 minutes, 40 to 45 minutes you can spend here, right? What about others? Only Divya is telling yes. Okay, okay. No problem. No problem, Divya. Yes, others. What about others? Are you okay with the classes Monday? If you have any problem, you let me know. We will postpone it. If you are okay with it, we will have. I don't have any issues. I can conduct, okay? But slowly, when you spend some time, no, then only we can go through all the classes. We can cover all the topics also. Okay? Okay, thank you so much for listening to the class. And if you are new to this channel, please subscribe so that you will get notification whenever I am uploading a class. And if you like the class, please give a thumbs up. And if you feel that it is useful and if you want to support the channel, please share it with your friends. Okay. Thank you so much for joining live. Take class daily. I am ready. Are you ready? I am ready. We will see. If we don't have time to complete, then we will do that. Okay. We'll see at least next week. We'll see. You have lab classes, no? So after that we can start. No problem. Okay, ma? Yeah, daily. That's what I'll see. Next week. After next week, we'll see. Right?